Hello, everybody, and welcome to today's webinar about the exciting and emerging topic of machine learning operations, otherwise known as MLOps. This webinar will showcase insights and understanding of how companies can fully leverage and implement MLOps. MLOps has a critical emerging role and has been named by Gartner as the future of data science. We have many attendees in today's webinar, and I'm very excited because this shows to me that MLOps is a very interesting topic. And you can go to the next slide. I'm the host of today. My name is Ralf Reich. I'm the VP within the European organization of SoftServe. And my colleague Volodymyr is a leading data scientist within the SoftServe organization. And he will explain how his team is ready to serve and deliver MLOps to empower clients like you in the new norm. The agenda of today is, of course, to show you the market momentum and the opportunity with MLOps. What is the status quo right now, where we are right now with MLOps, and where are we going, and how we enable those benefits across all stages. We will have within the presentation 3 polls, and I kindly ask you to attend to these polls because this gives us insights about your status in regards to MLOps. And at the end of the session, we will have a Q&A, and I kindly ask you to write your Q&A, your questions into the button on the top of this screen. And when we speak about SoftServe, we are a truly global company with more than 9,000 employees and 50 offices around the globe. And here I'd like to emphasize our Net Promoter Score of 75, which is far ahead of industry average, means that we are very proud of this because our clients seem to be very happy with our services. We have worked with some of the major clients around the world, and here are some key logos from different industries and different backgrounds, and this should also show to you that we are working very closely with these clients in regards to digital transformation journey. Before we go to the presentation of Volodymyr, we would like to ask you to answer the first poll. And this is the question: what stage of the maturity curve are you in regards to data science? And I would kindly ask you to answer these questions right now. We will have about 40 seconds to answer. So I'm very curious, what is the result of this poll? Let's wait a little bit. This will give us also an insight about your status. I think we have some technical problems, obviously. So let's announce the results of the poll perhaps a little bit later, and we can start with Volodymyr's speech about MLOps. So Volodymyr, is up to you.
Yes, hello everyone, and thanks for joining our webinar today. So our topic today is MLOps. We are going to discuss what is it, why is it called the future of data science or machine learning, and how can it actually help data science team and businesses in general But before we actually go into MLOps, let's make a quick checkpoint and look at the state of AI/ML and the state of the market regarding AI/ML applications. So humanity has been actually solving problems through all of our history, and we kind of managed to control the fire. We thought of round wheels. We figured out how electricity works. We then invented computers to help us to solve more problems and figure out how to work with computers by basically conceiving traditional software engineering and programming. And last tool in the row of our journey in problem solving is the AI. So in this particularly opinionated slide, we try to frame our progress in AI in a form of number of neurons. And as we can see, we are actually quite far away from the human level or intelligence, which is we generally call general AI. And instead, our best approximation and our best supercomputers right now operate at the level of a frog or a rodent, hamster, I guess. So just maybe a short notice, in this particular webinar, we are going to use AI and ML interchangeably. And when we are going to talk about AI, we first and foremost are going to talk about spatial AI. So if we think about spatial AI, even that particular level allows us to solve quite interesting and complex problems like computer vision. We are almost there with enabling and having self-driving cars. We are capable of doing speech recognition and natural language processing, and we beat major players in games. So, but we've been doing problem solving like for millennials, and we solved tasks with computers and traditional programming for more than 70 years. And foundation for those emerged even earlier. So why are we searching for next best thing? Why not just use traditional coding? We have so much experience. Well, it turns out that as we evolved as a species, so did our tasks and problems. And for those new tasks and those that will come after those new tasks, the traditional techniques and using them, it's either impractical or downright impossible because they suffer from what we call a complexity collapse. It's just too hard to frame the problem. And a nice example would be try to write a program that will recognize handwritten digits. As a person that tried that to do a long time ago, I can assure you that's very much not an easy feat. So if we can't do that ourselves, then what's our options? Do we have the alternative? And yeah, well, if we can't write the solution, well, then let's maybe have an algorithm write one for us. And in this new, completely different approach, what we actually, the major difference, so to say, is instead of relying on some experience and empirical rules, for the most part, we rely on the data and what the data is saying to us. In particular, for example, in supervised learning, we rely on the ground truth data, or so-called labeled data, where the answers are provided directly. For unsupervised or other types of learning, we might not have them, but we substitute those labels with something different. So all of that actually makes machine learning is a software of 21st century or a software 2.0. And that software helps us and is going to help us to solve the ever-growing complexity of our current and future tasks. It is scalable. It usually requires less domain experience, though not zero. It scales both computationally and with the amount of data thrown in it. And a nice side effect is that if we were to apply that to a more traditional tasks that we already solved, we might get and find better solutions. So, but why now? After all, like traditional methods of problem solving are still standing strong and they're not going anywhere. So, well, the Big Four actually laid the issue for us here, and we consolidated this on this particular slide, that since 2018, or maybe even earlier, the major organizations, the market leaders, are already competing using those advanced analytics and AI, and they are already sending ripples, earning more than average, and cutting into the pie that is estimated to grow as much as 15 trillion by 2030. And by current numbers, I believe that that's 14% of world's GDP. So looks like we found our next silver bullet, but actually, if we look at the market and the state of the market right now, it's not all that bright. So the study conducted by Gartner some time ago actually asked the question, how many of your models made that to production? How many of them are fully deployed? And it turns out less than half, 47%, some being partially deployed and some failing completely. And more recent polls by IDC confirmed that basically we are still there. Yeah, we grew up a bit and current number stays at 55%, but it's still quite slow. And in fact, this single thing is what prompted McKinsey to frame the inability to integrate as a major cause of why such initiatives fail, actually. So how come? What are the challenges though? And if we think about it, the machine learning is first and foremost the data-centric paradigm, and it can be a blessing. It is actually a blessing because we live in a world where the data is abundant to a point where it's called the new oil. And mostly thanks to World Wide Web, social networks, IoT, and other technologies. Some are even emerging technologies. But also it is a curse because when you have something in abundance, you basically stop taking care of it. And unfortunately, not all data is created equal and can be of any use. To deliver value from machine learning and from artificial intelligence, what we really need is the high quality data. So that means that this data must conform to a certain set of standards and rules, both from business perspective and from more technical standpoint to be of any use at all. And that also means that this data needs to be prepared before it actually can be used. The other major issue is what's called unclear success criteria. Whether in traditional programming, we have a set of nicely prepared set of specifications that was written either by business stakeholders, BAs, maybe product owners or team leads. And it's easy to compare the outcoming solution against that functional specification to see if we met the goal or not. With machine learning, it's actually slightly different because here we are optimizing some abstract metric, which can be quite not easy to reconcile with the specific business objective and can even be harder to communicate to our stakeholders. For example, how this nice high score transforms into my customer retention. The other issue is that while complicated as they are, machine learning workloads still grow and they grow fast. So both in number and complexity. As we conduct more experiments, we consume more data and we scale based on that data. So as we have more data, we need more memory to accommodate the data. We need more computing power in form of like general purpose CPUs or maybe something more specified like GPUs, tensor processing units, or some ASICs. And then we need more space to store the data. We need more network throughput to be able to transfer the data between one storage to another. And this increases the overall complexity that is there to the task. Well, let's talk a bit about the situation at the market and the perception. The standing perception was, and quite often more so than not, still is, that AI products are mostly about machine learning. So businesses and professionals tend to think that we trained the model, we tuned that, and we are quite good. We can really benefit from this. Reality, unfortunately, paints a slightly different picture. Machine learning requires engineering and quite more components than just tuning and training. So first and foremost, we need to ingest and get that data somewhere where we could start working with it. Then we need to analyze that particular data and figure out if it's of any use at all. We need to do some feature engineering from the data, which we'll then later put into our training and tuning. And only at that stage, we are starting modeling. So, and once we have the model, we need to evaluate that and persist that somewhere. This by itself concludes the development phase. And we have a nice model which sits there, but is pretty much useless from the business perspective. So to be able to deliver value from that model, we actually need to serve that to our customer. That means we need to ingest new data. We need to validate that data if it's a correct one. We need to do some feature extraction to match our model. And only on that particular stage, we can take our model and plug that into our prediction service. And it doesn't really stop here because once the service is live, we still need to monitor what's happening in there to be able to correct. And this basically conducts a serving pipeline. So if we look at our typical AI product team structure and hiring strategies, we can see that it's actually reflected. So we have usually those teams consisted of data scientists or multiple data scientists that are brilliant people that know how to create the models, know how to analyze lots of data. They even know how to do some engineering, which is totally great. But realistically, none of them is specializing on the software, delivering software. And as we mentioned, machine learning is software 2.0, but it's still software. So usually that means that we have a data science team that delivers ML, builds ML models, and we have a separate like DevOps software engineers that either part of the team, smaller part of the team, or from the outside team that come to the board and say, well, what's ML? What do I do with that? And in reality, if you think about it, that translates in the so-called typical machine learning project timelines. So when the core of ML, the model, is being developed in a month or even less than that, but then taking that to production takes anywhere from 4 to 6 to 9 months. And this is actually completely unacceptable, given that in some industries and some markets in our fast-changing economy, even 1 month can be very prohibitive. So, but imagine that we actually got the model in there. It's not the end, because operating those models is actually even harder. So it presents a whole load of new challenges, and some of them are important from the business or machine learning standpoint, like performance, model performance, and like model retraining, accordance to some rules and regulations, for example, compliance to GDPR. We also need to be mindful that we don't create any potential biases and we correct them sooner. And we also need to be able to explain why the particular model delivered a particular prediction or result. Otherwise, we might get in trouble, actually. Some of them are purely technical, some of those challenges, like availability 100% of the time, because you never know when your customer will come knock into the door of that model, or optimizing like latencies or throughputs. So all in general, as we can see, that the picture in market right now is not too bad, but rather grim. And in the next section, we are going to figure out how can we actually improve and where the future lies. With that said, let's start our second poll.
Yeah, thank you, Volodymyr, for this exciting speech. And we want to stop for a while. First of all, I want to apologize that the first poll didn't take place. We will do it perhaps later before the Q&A. But let's now do the second poll. The question is, in which areas of your business does AI, ML offer the greatest potential benefits? And I see a lot of members are attending on this. Let's wait for a moment. Looks like advanced services or business process automation is the highest ranking at the moment. Let's wait for a while. Yes, advanced services or business process automation. I think it's an important input for you, Volodymyr. Perhaps you can refer to this in your second part of the speech. Thank you for attending the poll, and yeah, we can move on. Thank you very much. So Volodymyr,
let us close the result and actually let us continue. So we've talked a bit about the current situation at the market and the challenges that companies are facing when they're working on AI products. So the question here, what the future holds for us, and can we actually do better, and can this process be less painful? And before we actually answer that question and talk about MLOps, let's define some metrics that are going to, let's discuss some metrics that are going to tell us that we are actually improving. And thankfully, fortunately enough, we accumulated enough experience to date to be able to at least attempt and define such measures, such metrics, for example. And some of those metrics will be purely from business perspective, like business impact, or I don't know, revenue, customer retention, things like that. The other will be more related to ML, which is like model performance or model reusability. Another will be purely infrastructural or like engineering things like chargebacks, which will reflect the costs and number of models deployed by on a certain amount during a certain amount of time, which will basically indicate our capability of bringing new models to our customers. And another set would be the processual or like dependencies, as we call it here. Like, for example, time that it takes for a data scientist to get access to a particular data. It's only like governance access. And also the time that it takes for data to become available to data scientists, because usually when you get that permission, it doesn't necessarily mean that you could go and use the data. Some process must happen. So based on industry experience so far, we know that a typical, or should I say ideal life cycle of ML project should look something akin to what is presented in this particular slide. So we are starting from ideation and planning and figuring out the business understanding, business context. And from where we proceed to experimentation, which is highly iterative process where data scientists are working on figuring out the solution to the problem and delivering kind of version of that solution. And once we get a version that we are happy with, we need to operationalize that somehow to put that to production to be able to deliver value out of this. And the process doesn't really stop, because after we have that running, we still need to monitor that, and we need to analyze any impact or insights that we are going to have to integrate that on our next iteration. So to support that life cycle, we actually need different skills and qualifications. We need operations engineer that are going to set up and maintain the underlying infrastructure that are going to deal with automation and things like security. We need data engineers, because everything starts with in ML, in AI, everything starts with data, at least in our current approximation to that. So we are having data engineers that are ingesting, preparing, and integrating that data somewhere. We are going to talk a bit about that later. Then we have data scientists that actually doing major heavy lifting, trying to figure out how can we use that data to deliver insights. And we have the software engineers, which take care of optimization of any scaling of integration piece. And they basically take care of the process adhering to the best standards. And to ensure the projects are delivered reliably in time and kind of without compromising quality, what we really need is we don't need those skills in silo. Instead, we are looking for synergy. And this is actually what MLOps gives us and what MLOps is. It's a set of practices that aim to automate and integrate the process between data scientists and software development and IT teams so that we can deliver result faster and reliably. And if that sounds familiar, that's because it actually really is. Because during the decades of problem solving, all these success, like new approaches, were usually built on success stories from the past. And our success story here would be at DevOps. So as we've been doing traditional programming, we have figured out the process for that and called that software development lifecycle, or SDLC. And also we figured out the set of practices that to make SDLC efficient and effective, which is DevOps. And basically, in our case, we are using DevOps as a baseline, as a base, but we have new addition, which is ML, which adds its level of complexity and needs new set of ideas to integrate to the older solution. So, and we need to be very careful not to think that MLOps is actually a skill or maybe a specific role or a position that some guy will come to us and will basically set everything and it's just going to work. No, it's more of a cultural mindset or a form of contract with key objective is to enable our data scientist and subject matter expert to develop and deliver models to customer fast and in efficient manner. And this is the mindset that needs to be taken and kind of thought and through all of the company. So let's talk a bit about the best practices of MLOps. And since this is basically a data-centric, data is a cornerstone, it makes sense to ensure centralized data management. And as we all probably know, data comes in all kinds and shapes, like real-time streams, data lakes, data warehouses, SQL, NoSQL databases, file and object stores. All the data, first and foremost, need to be ingested and processed properly and stored somewhere, which we're going to take a bit later. But sometimes the raw data is not enough. In that case, we will come and do some additional labeling or maybe supply some metadata annotations. Once we have that available, we need to consolidate that somewhere. And MLOps postulates and proposes that that somewhere is called feature store. And feature store is essentially the facility or tool that ensures smoother integration between data engineering and data science team, take care of training and feature data management and also data governance. It also helps and enables collaboration between multiple data science teams. So once we have the data integrated in feature store, we could actually start with model development, the traditional process that we know how to do. And once we have our model, we can deliver that to a production to serving, and it's essentially MLOps that helps us to do so in more efficient manner. And once we have data in like not the data but the model in production, we are going to take care of all the results of that operation and include that back as a kind of form of model feedback loop so we could improve on our next iteration. So it is important to mention that one aspect where MLOps differs from the DevOps is that there are way more artifacts to version. And like it stated here, in machine learning system, changing anything changes really everything. So let's think about the model building, model development workflow. So we are doing training data ingestion. We then do analysis of the data. We do some feature engineering, and we do training and tuning of the model. And then we also do evaluation. That's basically constitutes the traditional development process. So at every of those steps, we have artifacts that can and ultimately will affect the overall result. And that means that we need to version those artifacts to be able to go back and roll out, understand what happened, how we landed where we are, to be able to explain and maybe select the best case scenario, or simply to hand over work between team members from one data scientist to another. And actually, what makes sense to version control? Of course, it's a training data because everything starts from data. Then it makes sense to version environments like images, maybe Docker images, libraries, dependencies, because that by itself can affect what we get out of the result and maybe is a source of a randomness. We also need, since we operate on data, we transform data, and we need to keep that code versioned as well, so we understand how we landed there. It also makes sense to version features because we already spent so much effort and we don't want to do that again. Of course, we are versioning models and any metadata associated with them and experience working around the models. So good practice that can actually help with versioning, and not only with versioning, is what's called here a building block, is taking each step of our workflow, each part of the pipeline, and package that as a single atomic entity that acts into a function. So it takes some particular input and delivers some particular output that is in accordance to that input. And it enables reusability, it can help reproducing results, and it certainly eases testing. And also packaging flow into atomic entities can help us to move to the upper level of abstraction, basically to the level of workflow or a pipeline. A pipeline by its nature is a kind of cyclic graph of steps. And what it gives us a kind of reusability because we could always take out a single step and replace that with other one. Or we could basically operate on the pipeline level and replace the pipeline. And it also allows us to scale in any way we deem necessary or possible, or any way we want. And the nice thing, it also helps us to troubleshoot our work. So instead of trying to figure out what's happening in one huge monolith, we actually can go to the particular step that is failing and fix situation in there. So combining practices and ideas from MLOps with our DevOps past knowledge allows us to build kind of automated or semi-automated pipelines. And ideally, what we would like to have in our environment is a kind of split between the development sandbox, where we actually do run experiments and try our ideas, and the environment that is going to serve the customer and deliver value. And as mentioned, feature store is actually a bridge point between those two. So once we have the data scientist comes and in doing some sampling, he starts the usual workflow in the development sandbox. He goes through validation, preparation, the usual training, tuning, evaluation, and once he's done, he's actually has prepared pipeline code that he is ready to share. And important concept here that we all must remember is that our data scientists sometimes need a change of focus and shift in perspective. So what he is delivering during this phase is not the model or a report. Instead, it's actually a piece of code or a set of files that go into the source repository. And at that point, the machine learning phase of the process has ended. And what actually starts is the operations process. So in orchestrated manner, we deploy the code that was supplied by data scientists to the staging or production environment, where we actually run the very same workflow, but in this time, we're not working on a subset of data, we actually work on the full data. And during that, we could also keep some metadata storage where we would store all the information that might aid us on the next steps, next iterations, something that we might fix and tune. And once we actually have the model trained, we register that in the model registry. And at that point, our continuous delivery pipeline actually can take the trained model and put that to a service that is customer facing. That service, MLOps postulates basically that service also should work through a feature store to retain the same set of data transformations. So, and once we are serving our customers, we also need to keep track of what's going on there to catch any issues earlier and also include that data on our next phase. And this stage and production environment actually works in automated way, thus reducing the possibility of any human error or issue that could occur. It's of course not zero because software tends to break, but it's still better if we were doing that full manually. So it is also worth to mention AutoML, which by nature, like itself, makes ML more approachable to citizen data scientists, but it also helped more like traditional data scientists to be more productive. And by itself, that approach is not a part of MLOps, but development of such platforms, of AutoML platforms, greatly contributed to best practices of MLOps in our understanding how we should do that. And again, by its nature, since this is basically models trained by another models or any automated pipelines, it integrates very well into MLOps, into any MLOps pipeline, and thus it's increased value for both. So in order to summarize, what do we need to enable end-to-end machine learning operationalization and ensure successful delivery of our models to customers? We need to bridge the model development phase and the model serving phase. We have a set of usually missing nowadays, but those that should be there in the future, steps and maybe tools, if you would, which is model and data versioning, which is metadata and experiments, workflows, scheduling, deployment orchestration, in infrastructure management. So, and this is actually what MLOps gives us. And by giving that, by implementing MLOps, we can ensure that we have this kind of observability. We can tell what's happening in our system in any stage, from development to production. We have automation, thus greatly reducing timelines and maintenance costs. And we have reproducibility and consequently auditability of our pipelines, where we always can explain what exactly happened.
Thank you, Volodymyr, so far. First of all, I would like to encourage everybody to ask questions. We have on the bottom of the screen a Q&A possibility. So please ask question when something is unclear. And this is the third poll where we would like to ask you, what's your proposed timeline in terms of implementing MLOps into your business? And I see you already quoting here. So let's wait a few seconds. So it's a mixed feedback. At the moment, 1/3 of you are implementing right now. Later this year, also 1/3, and next year, I would say. So it's relatively equal. So some of you are already on the journey, and others, they will start a little bit later, but interesting feedback. Thank you for this.
Yes, and I would actually say that this reflects the polls, the studies conducted by companies like IDC and Gartner that actually show that some people already know that and trying to implement that, like those ideas that we should all come in the future. And some people are still looking at that. Maybe some are unfamiliar, but let us close the poll. This is actually where SoftServe and our MLOps expertise can come and help. So SoftServe actually has a long history of delivering software solutions, and that experience accumulating during like that long period helps us guide our clients through the whole journey from like incubating and implementing their ideas to maintenance and actually maintenance in production. And along that path, we also accumulated quite enough expertise that helps us working on horizontal solution level by, for example, a technology where the technology is main driver of the solution, being that some well-established technology like big data, or maybe something completely relatively new like robotics, deep tech, extended augmented reality, and also vertical solutions, which require more of a domain expertise, which we also already accumulated enough, and we can work in retail, supply chain, manufacturing, energy, you name it. So since many, if not most, workflows, AI workflows these days are moving to the cloud, and SoftServe being a partner to most of major cloud vendors, we can help by building infrastructure, processes, setting up those, building data ecosystem, implementing traditional analytics like BI, and also advanced analytics. And we can also help by building and integrating MLOps pipelines and processes to ensure success and quality of that delivered advanced analytics. And we usually try to follow the same path as we do in our other engagements. So where we actually guide our client from the very beginning, we can help with from the beginning through the ideation workshops and some discovery sessions in which we're going to assess what's going on, like the situation from the client's perspective. We will understand what the problem are the problems the client's facing, and we can then basically suggest a solution, go implement a prototype, do a full-scale implementation, and also help during the delivery and operation and maintenance. And just to conclude, with our support, you can turn your ML models into business value. Thank you.
Thank you, Volodymyr. I have to turn on my camera. Thank you. Very exciting, very encouraging speech. I think we can now repeat the first poll if this is available, what was not possible in the first place. So again, this is the first poll, and we would like to ask you, what stage of maturity curve are you in regards to data science? Let's wait a little bit. So far, we have more than 50% in regards to ML modeling and productionizing. I think this is the majority. Also very interesting for you, Volodymyr, to see this result. And yeah, thank you for answering this.
I would say it only makes sense because actually the people who want to hear about MLOps are the ones that are doing or trying to implement MLOps. So it's expected, and it's actually exciting that not only SoftServe and like big companies are working on that.
Absolutely. Okay, let's move to the Q&A session. Before we go to the Q&A session, I would kindly ask you to fill the feedback form. We will send it to you via email. And it's very important for us to get a feedback from you about this webinar itself and perhaps also other things, how we could potentially improve and what went well. It's very valuable for us. Thank you for giving us this feedback. So let's go to the Q&A session. We got a question from Mehdi to you, Volodymyr. The question is, what is the closest platform available at the market for E2E MLOps pipeline? Are you potentially able to answer this question?
Yes, sure. And so I don't think there's like a single answer to that question because it would depend on the requirements that we are bringing to the table. But and it's also build versus buy issue. When you can take a generic solution, maybe it's going to suit you, or maybe you need to build something a bit more tailored and it will be optimized to your case. But if we are talking about the platforms available, then most of the major clouds right now, for example, AWS SageMaker offer that end-to-end. Also, Microsoft is catching up basically with their DevOps and MLOps packaging. And of course, there is Google, which is also has their own like AI pipelines and AI hub solution. You could also talk about the smaller players like Data Robot. So those would probably be the most interesting right now.
Mm-hmm. Thank you for this. I have a question to you. So I'm taking the position of a client right now, or a future client. So what are the concrete steps when I would ask you tomorrow to help me in regards to the MLOps journey? What are the concrete next steps? How can you help me?
So yes, and we could refer back to actually our engagement roadmap. So first and foremost, of course, we will need to sit there and talk about the business case. What is the problem you're trying to solve? And then talk about your environment, things like where does your data come from, and how do you basically process? Is the data ready? Do you have like things like hidden consumers to that data? We will also discuss your infrastructure situation, whether you want to do that on-prem or maybe on cloud, or maybe you want something completely tailored, like specific hardware, things like that. So we will bring that to the table and we will sit there either in ideation workshop, which is a short version to generate ideas, how can we move forward? Or we could basically sign kind of a discovery which will be more involved, either on-site or remote. I guess in COVID world, it will be a remote, when we will go deeper into the case, figure out the solution, script that solution, and offer to implement that.
Super, thank you. So we can start tomorrow, yeah?
Definitely, we are available.
Super, thank you. So the team is available, yeah? So I think there's another question, or it's only answered. Okay, so again, I encourage you to ask additional questions, but in the meantime, I have another question to you. I saw the headline, MLOps cultural mindset. So does it mean that it's not only a technical matter, it's also something in regards to mindset?
It is actually not, and I would say that the technical is supplementary here. So any technology can help us, but it's not going to solve the problem. And the problem is usually in processes, in how we approach the situation. So typically, if we go there and look, we often see collaboration problem when we we have traditional software development lifecycle and processes around that. It works on one pace. Now we have a new addition, data science, that work in completely different velocity. And really, we need to reconcile that. Then we need then we have a situation like non-understanding between the teams regarding the data, for example. Why you need that data? We aren't going to give you that because like it's a sensitive thing. So it's either all company kind of adopts that mindset that we all work towards a common goal and we want to frame our business around AI. And this is how we approach that. This is the set of practices. And the technology actually comes after that.
Okay, got it. Thank you. We have another question from the audience. Which are the best recommended resources, books or MOOC to learn MLOps?
So frankly, to date, I've yet to see books published on that. And I've yet to see any complete online course that will basically guide you through. But for starters, I would suggest to search for initial paper about the technical depth in machine learning and just go through that to understand, like to frame the problem. And then a couple of good resources would be the blogs and the documentation from Google, which is certainly great, and from where we actually taking parts of our knowledge here as well. And also, I would also suggest to go through the YouTube route, where we actually have lots of talks where people are sharing their ideas, their approaches, and their success stories. This will give you far more information than any book that by the time it's going to get published, it will be outdated.
Okay, good answer, thank you. So I have another question from my side. When I look to the market potential, in regards to MLOps and how fast the market will evolve in this regards, how do you see this? What is the potential, or how fast will it evolve from your point of view?
So if we compare the two studies I mentioned, so over the course of 2 years, the initial Gartner study was in 2018, and the new one conducted by DC was in 2020, I believe, early 2020. So that's like a year and a half, a bit more. We've progressed 7% in like our success in delivering models. And please keep in mind, we are talking about delivering models, not actually a percentage of companies that are successful. We've seen the situation when a single company delivered one model successfully, but failed another. So it has been quite slow, but I believe that we are picking pace and it's gaining momentum, because now that we kind of frame the problem and figure out the solution to the problem, actually what we need is to brush on that experience. It will be the same as we went with the DevOps. So at first people are trying to understand what's that, why do we even need to do that? But soon after, it's like everyone started doing that and it really propelled us forward. I see the same is going to happen with the MLOps, and I think we're going to see increased adoption in the next couple of years.
I have another question. So again, I asked the audience also to ask questions. Otherwise, I have to ask one question after the other. So what could be also an interesting question? I think we heard a lot, how could it be successful, this journey? But what are the potential hurdles? Where could we potentially fail? And what do we have to consider in this regards? What is important from your point of view to consider?
Well, I would say that solving the issues, solving the task with artificial intelligence, like with machine learning, is still quite new like area to most of us. And we have inherent like dangers and setbacks there. So really, first and foremost, we might flop or fail when we try to address some issue, some situation with AI at first. Maybe that's not the best solution. Again, it's kind of it's the next best thing. We think it's the next best thing, but it might not be the silver bullet. And also the other like challenge that I see, especially in large companies, large enterprises, is this typical rigidity of the market, of the space in there. People are actually resisting new things and they are uncomfortable with those new things. And quite often building your business around AI and building, like integrating MLOps into your business poses like fundamental change in how you work before. So this can be another potential setback.
Thank you. I got another question from the audience. The question is, why do ML models degrade so quickly after deployment?
Well, technically, because I guess there are many answers to that question, but let's imagine the situation that we've developed a model on some set of historical data, for example, for the stock market, or, well, let's take a stock market. I think given the situation we are now, makes sense. And then it takes some time to productionize that, but suddenly, I don't know, COVID came, and people are starting focusing on other things, and like changes, like people started shifting their focus, ultimately changing the data, the nature of data. That's basically degrades our model by itself. That's one example.
Okay. We have a very interesting other question. The question is, do we understand you correctly that SoftServe would be the one providing the needed resources for MLOps opportunities, or would you also be able to advise, consult on existing MLOps teams? So that means the customer is already working with existing teams. Can we advise and consult also on this?
So SoftServe works both as advisor and as a provider, as we mentioned here. So, and in MLOps, we can either build from scratch, or we can help with, like, I don't know, maybe extending, maybe optimizing by offering some advice from our experience. Yes.
Yeah, I think it's absolutely correct, because we are on one hand advisors, on the other hand we are delivering the project. So in this regards, we could play the role of the advisors. Yeah. Another question. So now more and more questions are coming. I'm happy to see this. And we have still 7 minutes to go. So which technologies are available now to set up MLOps infrastructure on-prem?
It's actually a good question, and we're going like more deeper into technical details here, but I would say the same technology that the major cloud providers are using, because most of the technologies are taking like from open source and building something on top of that. For example, Kubernetes, it sits everywhere, and you can deploy that to cloud. You could use like already managed service, or you could deploy that on your on-prem cluster. And where you have Kubernetes, you have a tool like Kubeflow and Kubeflow pipelines, which are direct solutions, software solution, like platform aimed to provide like kind of technical support for data scientists, make them self-sufficient, basically adhering to MLOps. And also you have Argo if you want like more non-interactive approach, or maybe you don't need it. Instead, you just need a pipeline like the one I've described as a best practice, the automated CI/CD platform. So I would say those tools are easily available. And of course, we need to remember the good old Spark, which can also be used in there, for example, in conjunction with MLflow.
Okay. Another interesting question, and perhaps I would like to answer this. Is there a preferred vendor you are considering for MLOps, DevOps projects? I would say yes, of course. There's a preferred vendor. It's SoftServe. But the question was also, of course, where's the question? I don't see it anymore.
Yeah, actually, if we go to answered, you might see that.
It's already unanswered.
I'm not sure if we.
Yeah, the second part of the question was, if we are building already a DevOps platform with one vendor, would we be limited in our capabilities? Question mark.
That's actually a good question, though I guess we will need to clarify that a bit more. So let me try to answer that as much as possible here. So DevOps platform, if you have a DevOps platform and if you like embrace the DevOps practices, I think you will find it easier to embrace ML and MLOps into that pipeline, because like MLOps is built on top of DevOps. It's just that we are bringing another layer of complexity on top of SDLC and those practices. Certainly, it's not going to be like maybe the smoothest journey, but it's still going to be easier than setting everything up from scratch.
So what else do we have? Additional input to the earlier question. I'm referring to the cloud vendor, not services provider. That was a misunderstanding to the question before.
Yeah, so I can't really say that I have like a preferred one, because it all depends on the case and what I'm trying to work with. So for example, sometimes I find it easy to build process, to build platform around SageMaker, because it's so suitable for the particular case. In other side, I get the feeling that I'm bending that technology too much to basically to do my bidding to get the result that I want. And in that case, that moment, I've instantly figure out that it's actually Google's platform that's best suitable for that particular case. So I can't really say that I have. If I were to say about my favorite, I guess that won't be a cloud vendor, but that will be a Kubeflow, where I can actually tailor that to anything I want.
MLOps DevOps projects, question mark. If we are building already a DevOps platform with one vendor, would we be limited in our capabilities besides someone to lead the initiative?
I think we already kind of answered that one. Yeah, but then it depends on, I guess it depends on the vendor and their embrace of MLOps. Given that all major have kind of invested into MLOps, I think you shouldn't feel yourself limited. But again, we need to talk probably deeper about the case.
Next question. Are there any plans from SoftServe to build an ML platform covering the whole MLOps journey, mixing Kubeflow and MLflow?
So it's actually an interesting question, because SoftServe by nature is not exactly a product company that's building, or like a service company of that kind of service that's building platform and selling like that particular platform. And well, who knows, maybe that's going to change in the future. But in the meantime, we have like our internal sandbox, internal environment, which we call MLOps Lab, where we basically are building a foundation and doing experiments, testing various combinations, various workflows, life cycles, and various tools to see how they basically play together. And that includes both like cloud services and managed services, like, and completely open source, like take it and do whatever you want with that tools.
So we have 1 minute left. Perhaps the last question. Can you give an estimate of human resources and time needed to set up an MLOps platform? What are the important variations?
I would say that it would depend on on the basics, like where are we standing and from where are we starting our journey. And one of the questions was, if we are building DevOps lab, like if we have DevOps platform, are we going to feel limited? So for example, if your company hasn't really embraced DevOps yet, and like the software development process is maybe not fully automated, that means that we will need to first take care of that by setting up those particular practices. And only that we're going to start with MLOps, which is certainly a larger scope. But if you, for example, already have some infrastructure and what you need is do some kind of a modification, then of course we can easily skip parts, like some steps. Maybe we don't need prototyping, we just need a better assessment, and then actually go and work like on that change. So actually, and this engagement roadmap, it provides kind of typical timelines, but these can vary greatly, to be honest.
Thanks a lot, Volodymyr. It was a really great discussion. You gave us a very good insight, very good ideas. Thank you to the audience for attending this important session. Again, I would like to ask you to fill the feedback form, and we'll send it to you later on to your email address. Thanks a lot and have a very nice day. Thank you. Bye-bye.
Thanks, everyone. Bye.